If you take an ordinary clay pipe, fill it with coal dust, then seal the top of the bowl and heat it over a Bunsen burner, then, after a short while, put a lighted match to the end of the stem, you will get a continuous flame. By heating the coal, you have made crude coal gas. That is the simple principle, called carbonization, behind the manufacture of gas. At the gasworks, coal is heated in fireproof chambers, which drives off all the gas. The carbon that is left is cooled and used as the smokeless fuel you all know, coke. Meanwhile, the crude gas is passing through cleansing processes which extract the byproducts: tar, the basis of many products and industries, benzol for motor spirits, and fertilizer for agriculture. Then the gas goes into store in the holders, from which it travels to the consumer. Gas as you know it. Coal for gasworks comes mainly from the mines of Durham, Northumberland, and the Midlands. Their coal is specially suitable in making gas, and it gives a good quality coke. From the pithead, the coal travels to the gasworks, often by special sea-going colliers, which bring the coal up the river to the unloading piers. Here, great grabs, which take a mouthful of 3.5 tons at a time, transfer the coal from the ships onto continuous travelling belt conveyors. The belt conveyors carry the coal up to storage bunkers, where it is crushed and blended and waits to be carbonized. Well, now that we have got the coal to the works, we can see about turning it into gas. First, let's have a look at this diagram. As you see, there are 4 ways of making gas. In horizontal retorts, water gas plants, vertical retorts, and coke ovens. Let us first take horizontal retorts. Here is a bank of them. The retorts are long, D-shaped chambers, stretching the width of the bank and set in groups above each other. Coal is brought from the store by overhead railway into the retort house and emptied into the bunkers. From here it is filled into the top of the charging machine. This machine runs on rails the whole length of the house. When a retort is to be charged, a belt on the charging machine, moving at great speed, is put opposite the mouth of the retort. The coal is then fed onto the belt, which is moving so fast the coal shoots forward into the retort. About 1,200 weight of coal is fired into each retort altogether, and the process is repeated right down the line. For 9 to 12 hours, the coal is being baked at a temperature of nearly 2,000 degrees Fahrenheit. At the end of this time, all the gas has been driven off, and only red-hot coke is left. Then the discharging machine is brought into play. Like the charging machine, it runs on rails. A big ram is brought opposite the retort and drives out the red-hot coke. The coke falls out at the other side, and when the retort is empty, it is at once charged again, and the process continues. Some of the coke is used to charge the furnace which heats the retort from below. The rest is cooled and carried away from the retort house on endless belts. It travels to the coke plant, where it is graded into different sizes. Coke is the first great byproduct of gas making. The large coke travels to the pier for shipment all over the world. The medium is the smokeless fuel you burn in your homes. while the very smallest, called breeze, travels to the boilers for steam raising. The water gas plant is the second of the four main ways of making gas. Coke is burned in a generator like this, and when very hot, steam is blown through it. This makes a gas known as water gas, which is made richer in a carburetor by squirting a fine spray of oil into it and goes to mix with the ordinary coal gas. The water gas plant is generally used for meeting sudden unexpected demand for gas because of fog or cold snaps, like the one at Christmas 1938, when all gas-making records were broken. Its great advantage being that it can be started up quickly and is very nearly automatic in working. Vertical retorts are a development of the horizontal retort, in which the chambers are set on end. The retort chambers are rather larger than in horizontal retorts, holding over a ton of coal. Coal is mechanically raised to hoppers above the retorts. From here it is automatically fed in the correct quantity into the retorts. By the time the coal reaches the bottom, all the gas has been driven off, and the rest is automatically discharged as coke, already cooled, onto conveyors waiting to receive it. Finally, there are the coke ovens, where everything is done on a large scale. Each oven is the shape of a bar of chocolate set on its side. These ovens are in batteries of 30, and each oven can take a charge of about 16 tons. Crushed coal is delivered from the storage hopper into the charging machine, which moves along on top of the ovens. The heat for carbonizing this coal is provided by gas coming from a special water gas plant adjoining. After 19 hours, the coal has been carbonized. This ram drives out the red-hot coke, which falls out on the other side into a truck. After collecting all the coke, the truck goes under a tower where the coke is quenched. Then it is discharged onto a wharf, from which it finds its way to the central coke plant. Well, now we've got gas from one of those four ways of making it. But when it leaves the carbonizing process, it is crude gas, quite unfit for use. It contains many substances, some of which have to be taken out by law before the gas reaches the consumer. Most of them are also extremely valuable as byproducts. Even as the gas comes away from the retorts in pipes, it is depositing tar, oils, and water, which drain away to underground wells. The gas, of course, is still very hot. It is cooled down by passing it through condensers, where it passes over pipes with cold water flowing through them, or through pipes with cold air circulating round them and water dripping over them. As the gas cools, everything in it that at normal temperature is not in the form of a gas condenses, that is, becomes liquid, and flows away to join the other liquids in the well. After passing through the condensers, the gas comes next to the exhausters. These are pumping machines, which by creating a vacuum, suck the gas from the retorts through the condensers and send it on under pressure through the other purifiers. The gas next passes through the Livesey washers. These make the gas bubble through a foaming bath of liquor, which removes the last trace of the tar. Tar is a most valuable byproduct of gas making. Over 2,000 different things can be obtained from it, including disinfectants, medicines, perfumes, toluol for explosives, dyes, saccharine, pitch for electrodes and other manufactures, creosote for wood preserving, and, of course, tar for road making. The next purifying process is carried out in the washers. These are divided into several successive compartments. In each compartment is a fan-like arrangement of metal or wooden bundles turned by machinery. At the bottom of the washer is a well of liquid. Gas is forced in at one end and goes through each compartment in turn. It has to pass against the surfaces of metal or wood, which, as they turn, pick up the liquid from the bottom and wash the gas with it. Now, various liquids have what is known as affinity for various substances. That is, they absorb those substances. So by varying the liquid in the washer, different substances can be extracted from the gas. For instance, ordinary water has a great affinity for ammonia and can actually absorb 900 times its own volume of ammonia gas. So if water is filled into the washer, it will extract the ammonia from the gas. Ammonia is of great value as an artificial fertilizer in the form of sulfate of ammonia, and it is also used in making baking powder, smelling salts, artificial silk, etc. Next, the gas passes through dry purifiers to remove the sulfur, which is in the form of sulfuretted hydrogen. The purifiers are full of moistened oxide of iron, which absorbs all the sulfur. When it is finally saturated with sulfur, it is discarded, and the sulfur is extracted from it and used for making sulfuric acid. After that, naphthalene has to be extracted, otherwise it would clog up the mains and service pipes. This is done in an ordinary washer or scrubber, using oil as the washing medium. Nowadays, an important process is the extraction of benzol. This is often done in a special plant. The gas is passed in an absorber through activated carbon, which absorbs the benzol. Then, by the use of steam, the benzol is driven out of the carbon and flows away as a liquid. Benzol, of course, is extremely valuable in the making of motor spirit, and over 3 gallons of spirit can be obtained for every ton of coal from which gas is made. This is the final process of byproduct extraction. Not only has the gas been made fit to use in your home, but very valuable byproducts have been won, which go completely to waste when coal is burned raw. Coal is a valuable national resource. How can it be used to the best advantage? 100 potential heat units of coal, burnt raw in an open grate, will give you about 15 therms of useful heat. 100 potential heat units of coal used to produce electricity will again give you about 15 useful therms. But 100 potential heat units of coal will, if turned into gas, give you 12.5 useful therms from the gas and another 12.5 from the coke, making 25 useful therms in all, not to mention the value of the byproducts. Back again to our gas making. Finally, any excess moisture is taken out of the gas by passing it through a solution of calcium chloride, which absorbs water. Then the gas is measured in station meters, and ready for use goes into store in the holders. There are 2 main sorts of holder, the water-sealed and the waterless. The water-sealed holder is a telescopic hollow container, resting in a basin of water. As the gas comes in, the holder extends itself to give it room. As gas is taken away, it falls again, and the water it floats in seals the holder and prevents the gas escaping except by the main. The waterless holder is simply a round, hollow container firmly fixed to the ground. Inside is a piston, which rises and falls according to the amount of the gas. From the holder, the gas is pumped through the mains to all the homes and factories where it does its never-failing job of providing heat on tap.